Right, hi everybody. Welcome to day 3 of Advent of GPU Code. I'm trying to go through all of the Advent of Code problems as they come out and write a solution for them using just the GPU for computation. I'm doing this in Python, and I'm primarily using Number with the Number's CUDA support to do this. So let's, if you have any questions, there's like a link down the bottom. I've like answered a bunch of common questions on there, so you can go and find out kind of what environment I'm using and tools and that kind of stuff. So let's head over to Advent of Code and have a look at day 3's problem. So within the toboggan login, with the toboggan login problems resolved, you set off towards the airport. While travel by toboggan might be easy, it's clearly not safe. So there's very minimal steering in the area, and the area is covered with trees. Oh, I really can't read today, sorry. You need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map, which is your puzzle input, of the open squares, dots, and trees, which are the octothorpe, the hashes. You can see, for example, here's a thing. These aren't the only trees though, due to something you read about once involving arboreal genetics and biome stability. The same pattern repeats to the right many times. Okay, so it wraps around, basically. You start on the open square, which is a dot, on your top left corner, and you need to reach the bottom below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope, right 3, down 1. From your starting position at the top left, check the position is right 3. You would encounter for the slope, right 3, down 1. From your starting position at the top left, check the position that is right 3, down 1. Then check the position that is right 3, down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked with a 0 where there's an open square and an X where there is a tree. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of the map, following the slope of right 3, down 1, how many trees would you encounter? Okay. That's fine. So we've got our puzzle input. This is we have an array, right, of these things. Let's get the puzzle input first. Fine, okay, so it's quite tall. Let's copy that. And let's create our puzzle input over here. So new file, let's rename it input. Just paste that in there. Okay, so starting from here, we need to go right 3, down 1, and see how many trees there are. And when we hit the edge, we need to wrap around. So we're kind of coming across this again, which we could do with indexes wrapping around. That's fine. So I think the first thing we want to do, let me just reload my GPU dashboard frames. The first thing we need to do is read all of this into an array. It's already pretty straightforward. Let's do that. So I'm just going to open yesterday's solutions just so I can copy some of my imports just to speed things up a bit. Let's go with that, and then with open input.txt. Okay. So we'll have input equals read lines. Input. What did I call it yesterday? Inputs. Okay. Inputs equals read line. fh.readlines. fh.readlines. Read lines. Okay. So let's run that, and then let's have a look at our inputs. Our inputs looks like that. That makes sense. What we need to do now is split this up into a NumPy array of something. I might go for just like 0s and 1s, just to represent these. So 0 is a free space and that. So what I first need to do, just trying to think of the best way to do this. Let's just do for row in inputs. We need to do, let's just do row equals row dot strip, and then row equals, we want numpy array, right? So we want like an np dot array or as array of our row, but we want to like split like that, and then let's have actually, if I go strip there, I could do this as what did I call it yesterday? We called it entries yesterday. I'm gonna call it problem today. Or maybe map. Slope sounds fun. So slope is going to be an np array of that'll be np.asArray, and we do a list comprehension, which will be np.asArray of that. What does that do? Row is not defined. Yes. For row in inputs. What does slope look like? Do I need to go like that? No, empty separator. Let's just go Python split string to list of characters. And I just call split on it. Am I doing that wrong? Row dot strip and split. Oh, I think I missed a bracket. There we go. Split is not defined. Oh, right. Okay, so I could do that in here. I could just say C for C in my row like that. Yeah, that's going to give me that. And then we'll have do this as like a Boolean array, I guess. I could have C equals a dot. Right, so we've got our true and false array, which I think is probably just an easier thing to deal with in GPU land. So next what we need to do is map over this, right? So we need to do something like, for the length of the table, let's just copy some more code from here. So I want that, and we'll call this slope and pass. I'm also going to take we had this like answer array, right, which is just an array with 0 in, and we did atomic adding to that answer, so we're gonna just take that in. So we'll do slope and answer and calculate trees, and then let's just copy my threads per block and blocks per grid and all that kind of stuff. So it's gonna be length of the slope, and then we need to call it like that. So calculate trees. Yeah, that's fine. It needs to be slope there. Okay, so it's 323 threads. No, 323 rows. That's what I've ended up doing here. But I don't want to do it in rows. I want to do it in groups of 3 rows, don't I? Because like each iteration of the GPU, I want to inspect 3 rows because it's telling us to go right 3 down 1. Okay, so we are going down every row. That's fine. So we need to do 323 things. And we've got our absolute position, which is our row number. So we want to do if our slope at position, so at row position, right? But we want to go down, so we want to do at row position plus 1. We don't want to check the last row, do we? We want to do -1 here. Like if position is less than length of slope -1. We want to, oh no, maybe I'm going to put that there. So if our slope position plus 1, which is down 1, and right 3, let's just have a look at, if I do slope 0, 1, that's false, which is that one, and 1, 0 will be true because it's there. So that's 1 is the row count, so there, and then that will be position times 3. No, position times by 3, but then modulo the width, right? So we want slope dot shape 1. No, I just can't type slope. Slope dot shape 1. Let's do that. Modulo that, right? So we're getting our absolute position there. So if not that, because it's Boolean. Yeah, okay, let's flip this actually. So we want true for trees. How is it not an X? Not an X? Oh, that's yesterday. Row 3 input. Oh, it's a hash, isn't it? Not an X. If it is a hash, it's true. All right. So if that position, right? If that position is true, then add 1 to our answer. So we're going to like map over the whole array, going down like that. And the answer it's given us is 68. There would be 68 trees if we did that. That's not the right answer. Darn. Okay. Let's sanity check this. So go right 1. Where's length of slope? Is the number of rows, right? And if I do slope dot shape, yeah, 323. Length of slope 323. So yeah, we want to do a call for every row, and the row is going to inspect the following row. 10 to day 3. So starting from here, you start on the open square dot in the top left, and you need to reach the bottom, below the bottommost row on your map. Maybe I don't need that -1. Well, that's giving me a completely different answer, 136. I'm curious, I'm going to try it. 136. That's not the right answer. Your answer is too low. Okay. The position is less than the length of the slope, which makes sense because we are going to have there's 3 blocks per grid, right? So that times 3 means we're going to go over 384 rows. So we need to make sure we are inside the array. And then if slope position plus 1, I'm wondering if I've got this wrong, but let's go like height and width equals slope dot shape, and then I'll put that in there, and I'll put that in there, because that's what I would expect, right? Height is 323, width is 31. The position times 3, and modulo the width to wrap around. I'm just curious, if I do slope 0, 1000, index error. Oh, now that's giving me a different answer again. Oh, it's giving me different answers every time. Oh, it's because I'm not resetting. 68. I need to put, I'm going to put this in here. Just so that it, every time I run that cell, I'm not like rerunning it. I'm just curious, if I do output equals mp.zeros width, I did define that down here. No, height, or length of slope, right? And I'm going to pass output in here, and I'll put output in there. And then I'll say output position equals 1, right? I'm just curious to see what that output looks like. If I do a sum, I'm expecting this to give me 68 as well. Yeah, because we're just taking the individual outputs here. I would just take in the, it says like no tree, no tree, no tree, no tree, no tree, tree, and so on. I might just look at it with my eyes and see. So we go right 3, down 1, no tree. Might just try printing the slopes. Oh, wow, I did not mean to do that. That's probably too big now. There we go. Let's have a look at the input. So we go 1, 2, 3, down. That's no tree. 1, 2, 3, down. No. 1, 2, 3, down. No. 1, 2, 3, down. Yes. Okay, that looks right, as in no tree. Oh, maybe it doesn't look right. No tree, no tree, no tree. This, it reckons it's got 1, 2, 3, 4, 5 no trees. Right, but we've got like the fourth. This first one is going to be positioned like this, 1, 2, 3, right, which is no. This is going to be, this one here is going to be row 1, 2, 3, 4. 1, 2, 3, 4. And it'll be 3, 6, 9, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, position 12 is a tree here. So why are we not? Let's just copy that. I just want to say X. Let's just say X, right? And I'm going to put X into my output. Instead of setting it to 1, I'm going to move it here. I'm going to put it into my output array so I can look at it. Yeah, so we've got 0, 3, 6, 9, 12. I should have kept my last array, shouldn't I? 15, 18, 21, 24, 27, 30, and then 2, 5, 8. That looks how I would expect it to look, I think. But something's gone wrong. Or is it like 1 counted, maybe? No, this would be position 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. 1, so 1, 2, 3, 4, 5. 1, 0. I should be 0 counting, shouldn't I? 0, 1, 2, 3, 4. We've got 0, 1, 2, 3, 4. We got 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Confusing myself slightly now. This is probably going to be like a 1 counting thing or a 0 counting thing that I'm just getting wrong. So I need to go for 1, 2, 3. Actually, I wonder if I should be starting in this top right hand corner. The first one, position 0, should be position 0, which makes sense, right? 0, 0. We start at the top right, top left. Top left corner, position 0. And then if slope position X. Oh, let's give me 200 now. Hooray! Okay, good. That makes more sense. I just had my I was counting wrong because I wasn't skipping the first row. So I got 1 gold star. Continue to part 2. So let's call this. Let's get rid of that. Don't actually need my output at all here now. I was just using that for debugging. Get rid of output here, output, and output there. Just run it again. I don't need to see my blocks per grid either. I think that's unnecessary. Okay, so I can see 200 there. So let's call this part 1. That's our input data. Part 2. Time to check all the rest of the slopes. You need to minimize the probability of sudden arboreal stop after all. As in, don't hit the trees. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Right 1 down 1, right 3 down 1, right 5 down 1, right 7 down 1, and right 1 down 2. In the above examples, the slopes would find 2, 7, 3, and 4, and 2, respectively. Multiply together, they produce the answer 336. What do you get if you multiply together the number of trees encountered on each of the listed slopes? So I've made some assumptions in here that I guess we need to challenge now. The main one being this down number, right? Because I effectively want to go over this grid multiple times. I could put that into here, right? As in like do multiple checks. So that is, I'm going to move X into there as well, just to tidy that up. So if I now copy this, calculate, let's call this calculate many trees. And I'm going to copy my call down here as well. I'm going to call this calculate many trees. I'm going to call this part 2. Part 2. So, I mean, I could literally do something like make my answer more than one, as in like I'm doing 1, 2, 3, 4, 5 checks here. Right, so I could make that 5 outputs. Sorry about that. Make that 5 outputs, and then we're going to go right 1 down 1. So right 1 down 1. And that'll be the first check. That's going to give us 66. And then we could do another check. So we could do, we're going to go right 3 down 1. Right 3 down 1, which is what we did before, but we're going to update the next index in our thing. So we get 200 here, which is what we had before, right 3 down 1. Now it's going to be right 5 down 1. Let's have another one. Right 5 down 1. Oh, I haven't updated my thing there. We go right 5 down 1, 76. And then right 7 down 1. Right 7 down 1. And we'll update the next answer. Gives us that. And then the last one is right 1 and down 2. So what we need to do is right. Yeah, right. So I need to go right 1, but we need to go down 2. So if we basically just want to do this on even numbers, right? So if position is, because we're brute forcing through everything, right? But we're going to kind of check every row still. So if position modulo 1 and right, let me just check. Let's just do 0 modulo 1, 1 modulo 1. No, it's modulo 2, isn't it? And what if it's a boolean is true? Let me just Google this. I can never remember. Python check even number. Check number odd or even. Oh yeah. If position modulo 2 equals 0. That's what I want to do. We will update that, which will give us 30. And then we want to multiply all of those together, right? Multiply it together. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Let's just do numpy multiply all elements, all items in array. Prod. Numpy.prod. That's what I wanted. mp.prod x. We want mp.prod answer. Is that number there? Is that the answer? That's not the right answer. Your answer is too slow. Darn. Thought I had it. Wait. Yeah, that makes sense. Position. I think because we're skipping rows, I need to go down 2 still, right? Or is it? No, wait, let me read it again. Return to day 3. Because I'm going right 1 and down 2. I'm going down 2 and right a half. So that's going to be divided by 2. Oh, typing error. No implementation function found for signature. I don't know what I've done here. Can I do? I mean, I was doing ×1, right? Which worked. But if I do times a half, typing error. Why can't I do that? What if I did ×1 like that? No, still typing error. A half. Slope position makes sense, and then the next position is going to be position. These are the little things that trip me up. Let's just try breaking this down a bit. Pos equals pos by 2. we're done. Let's do x. X equals pos by 2. Put x in there. I've got a typing error. Is it going to give me something more useful here? Can I cast that to an int? Is that what I need to do? Yes, that's what I needed to do. I needed to cast that to an integer. Right. These are the things that like trip me up in number, but I got there. I got there. So I could probably wrap this back up again, but and then my answer is now that. Let's have a look and see if it is happy with that. That's the right answer. Hooray! Amazing. Okay, return to your advent calendar. Good. I feel like I'm maybe slightly getting better at this now. So I the first day this took me like an hour and a half. Yesterday it took me 2 hours to get to this. I now did this one in 30 minutes, which is good. I think yesterday I learned a lot about dealing with strings in number, whereas today this was, I could just deal with booleans, and it was just a simpler thing to think about. I could think about doing this differently, but that's it. So that's day 3. I hope that was useful and interesting. I definitely am learning some things as I'm going through this and enjoying working through. So I think I'm gonna keep going with it. And I will catch you all next time.